Okay, so we're continuing through page 3 here. We talked about the halogenation reaction last time, so this time we're going to go through this reaction. Here we have our hydrohalogenation. Right, so we're adding the H, we're adding the Br. It is an acid, right? We got a cation intermediate and all the ideas that go along with that, right? A racemic mixture. If we do form a chiral center at the end of it, or a chiral carbon, I should say, and shifts and rearrangements and stability and all those kind of things. So anyway, let's work through this, right? So again, we make an assessment. We have our two carbons involved in the double bond, the red and the black. Which one of those is going to be the more stable carbocation after our first step? The red one is the more substituted. That's what we're going to do in this case then. So remember, our double bond swings out, grabs that hydrogen. We make a bond, we break a bond. Right? So we got our 6 carbons. That was a little bit slanted. Sorry, let me adjust that. Okay. Here and here. Right, so we, let me bring in some color. Right, so that red hydrogen, gets added to the less substituted side, right? And that means we leave behind our carbocation on the more substituted carbon. So remember, every time you form a carbocation, always make sure you ask yourself the question, is there a more stable carbon next door, right? And remember, next door, I'm talking about here or here. Are any of those carbons next door more stable? Well, we're at a secondary carbon, right? We're at a secondary carbon. Here it's primary and here it's secondary. Right, so next door there's nothing more stable, so we're not going to worry about any shifts or rearrangements in this case. Once we have the most stable plus, then we can bring in our minus. And our minus in this case is going to be the bromine. So bromine comes in, whoop, there we go. It makes that noise while it comes in, and so there we have our answer at the end of it. But if you'll notice, right, that black carbon is a chiral center. So we will make our R and our S versions of it. And so you could sketch those out, right, where we have that and that. Okay. And remember, that's because of the planar nature of that carbocation. That bromine can come in from the top or the bottom, right, the wedge or the dash, if we want to think about that. Okay, moving on here. Here we have our acid catalyzed hydration. Okay. Again, we're using an acid, so we likely have a cation intermediate, right, which brings in all the points with it, racemic mixture and shifts and all that kind of stuff. And it is catalyzed, so we better reform our acid, right? If we start with the acid, we better end with the acid. That's what it says. Okay. So let's go through this. You'll notice that here, let me bring in some red. These two carbons are identical, right? This is a very symmetric molecule, right? And you can see that internal plane of symmetry. So both of those carbons are the same. So we don't have to worry about choosing one over the other. They're functionally identical, I guess might be another way of looking at it. And so let's start out by making our alkene, right? The alkene swings out, grabs a hydrogen, you make a bond, you break a bond, right? So the alkene grabs the hydrogen from the acid. Okay. So let's say that we left behind the plus there, and that means that this hydrogen here, right, we could just say that that hydrogen there got added there, okay? You could have just drawn the inversion of that too, where we swap the plus and the H. Remember, it doesn't matter in this case. Now we have to stop, ask the very important question of what's next door to that carbocation, right? We're currently at a secondary carbocation. If you'll notice over here, we have tertiary, and over here we have secondary. So there is going to be a shift, right? We're next door to a tertiary, so we are going to do a shift. Let me just erase that, clean it up. Okay. So we look next door, we establish that there's a tertiary carbon there. And if you shift from a tertiary to a secondary, that's going to be a hydride shift. So we're sending that bond over there. Okay. So now what happened? So now let's mark this in red. So that's the hydrogen that got shifted with the hydride shift, right? This guy here. Okay. We could, just for clarity's sake, bring that orange hydrogen still in, right? That's the one that originally came from the acid. And then our carbocation is over here, right? It's on the tertiary carbon now. Okay. Now, we recall that acid-catalyzed hydration is run in aqueous media. Okay, so we have plenty of water around. So let's bring in some water. Let's bring in some water to do the next step here, right? We've generated the most stable radical that we can. So the next step is just to send in our negative, right? So the water comes in and hits our most stable carbocation, right? Let's just draw that a little bit better. Okay. So we have our green bond there to our water that came in. All right, we got the plus charge on that oxygen because we have 3 bonds to it. So the problem we have to deal with now is getting rid of that plus charge on the oxygen. So some more water is going to come in and help it out. Make a bond to hydrogen, break a bond to hydrogen. I like when my computer kind of snaps that image in place there of the nice clean cyclohexane ring. If only I could draw that nice. Okay, so there's the green hydrogen that came in from, the green alcohol that came in from the first water, right? The green water there. We have this water over here, right? Which plucked off that green hydrogen there, which reformed our acid, right? We reformed our acid. That's one of the things that we have to do, okay? All right, so there is our mechanism for acid-catalyzed hydration. Oops, sorry about that. Our acid-catalyzed hydration. We have to bring in some water as solvents, right? Or we have to bring in some water because it's a solvent to kind of do some of the shuttling around of protons and things like that. All right, so that is the end of page 3. I'll just zoom out here so you guys can see everything. And in the next video, we'll move on to page 4. Well, if I can tell the recording to stop. Okay.